The objective of this lab was to find the durability and toughness of certain materials using an Izod impactor. The materials we used in this lab are Izod impactor, brass, steel, and aluminum. This lab was designed to help us show the effect that kinetic energy has on the strength of a metal sample. Using the Izod impact test, we tested the toughness of 3 metal samples. In this test, we use an Izod impact machine to swing a hammer at a notched piece of metal to test how much force was needed to break the sample. The Izod test is most commonly used to evaluate the relative toughness or impact toughness of materials, and as such is often used in a quality controlled application where it is a fast and economical test. It is used more as a comparative test rather than a definitive test.
You pull the pendulum to the right and secure the pendulum onto the metal safety block against the anvil to hold the pendulum out of the way. After securing the anvil, you clamp the given sample material into the pendulum impact test fixture, ensuring that the nut side of the sample facing the striker. With the help of a gauge, you make sure that the center alignment of the notch is in line with the top surface of the vise. We now ready the pointer indicator for the amount of energy used to break the sample. We then raise the pendulum counterclockwise by hand to the low latch position and then listen for a click that would indicate that the pendulum is latched. Now that the pendulum is latched, you want to ensure that all personnel and objects are out of the way. After doing so, release the pendulum by quickly moving the operating lever from the latch position to the release position. Once the pendulum swings and breaks the sample and rotates the pusher arm to the position, the pointer on the dial to the energy reading used to break the sample. Once the pendulum has completed the initial swing and begins to move back toward the anvil, you remove the stop pin from hole 2 and place the operating lever in the brake position. Once the pendulum has stopped swinging, move the operating lever to the release position and place the stop pin back into hole 2. Read the pointer indicator for the amount of energy used to break the sample. Once you have recorded the pointer indicator for the amount of energy used to break the sample, you're going to want to record the pendulum's angle of rise. After recording the pendulum's angle of rise, you raise the pendulum onto the metal safety block. After doing so, you could then release the sample from the clamp and take proper records of the sample material for your report.
Okay. Now we are going to the calibration part. First, we will know what will be provided in this lab. So the given values. Given mass of striking hammer, which is 12.07 kg. Height to which the pendulum is raised, A. This is 4.573 meter. And the length of arc of pendulum, R, which is 0.8 meter. Alpha, angle of fall 73.5 degree. And last one is impact velocity, which is 3.35 meter per second. These values are already given in the lab report, and now what do we calculate in this experiment? So we record beta, which is angle of rise. We are doing this calculation for the aluminium part. So angle of rise for the aluminium is 64 degree. And the energy absorbed by the aluminium is, this is the recorded value of energy absorbed, which is 11 pound-feet. In metric it is 14.9 joules. So we have to find 5 things in this lab. First, we will go with the potential energy. Potential energy. Potential energy is of 2 types: initial potential energy and the final potential energy after the impact. So first, the initial potential energy, which is equal to mgr 1 minus cos of alpha. You know what is m here, what is r here, and what is alpha. I already explained. So the g is the value of the gravity here. Now we will put all the numbers here. We will do all the calculations in the metric form. So the numbers are, for mass it is 12.27, the value of g is 9.8 meter per second square, and the r is 0.8, and 1 minus cos of, the angle of fall is 73.5 degree. So I will do just a quick calculation like I already calculated for these stuff. The initial energy comes 67.7 joule. Now we will calculate the final energy, which is mgr 1 minus cos of beta. The numbers are very same, but now we will consider the angle of rise, because this is the final energy which comes after impact. I already calculated the final energy too, which comes 53.13 joules. That's great. Okay, this is our fourth part, what we calculate the potential energy. Now we will calculate the height after impact, which is, let's suppose it is B. From the above theory, what we explained in the above part, B equals to R1 minus cos of beta. Beta, you know the angle of rise. So R is given 0.8 and beta we calculated 64 degree. I already calculated the value of B, which comes 0.449 meter. Now we have to calculate the energy absorbed theoretically. We recorded the value of energy absorbed experimentally. Now we will calculate the energy absorbed by the material theoretically with the help of final and initial potential energy. So theoretical energy absorbed. Theoretical energy absorbed is equal to initial potential energy and minus final potential energy. The values of both we already calculate. So the theoretical energy absorbed comes 14.57. From here you already see that there is a slight difference in the values of theoretical energy absorbed and the recorded energy absorbed. So now we will calculate this percentage error. What is the difference between these values? So the percentage error this is equal to theoretical value minus recorded value over theoretical value into 100. I already calculated the percentage error, which comes 2.27%. From here it is confirmed that there is a slight difference in the values of theoretical and recorded. So our experiment is pretty much right. Now we have to calculate the impact velocity. We have to verify that the impact velocity is equal to 3.35 meter per second. So the formula for the impact velocity, as we already discussed in the theory part, is equal to root of 2gh. Here h is the height, and we consider the value of height as a. So we will put a here. The value of a is 0.573. Comes 3.35. I already calculated this value. So from here we see that the value of impact velocity is same as we have already given in the lab. So our impact velocity is verified. And now, where is the next page? Okay. Now we will verify the initial height of the pendulum. So fifth part, initial height of pendulum A, which is equal to R1 minus cos of alpha. Yeah. R is already given. 1 minus cos of 73.5 degree alpha. The angle of fall is also already given. So here it comes 0.573 meter. So we see from here that the value of A is same as we have already given. So our initial height of pendulum is also verified. Okay, now the last part comes ISO impact strength and ASTM impact strength. So the question is what ISO impact strength actually is. ISO impact strength is the energy absorbed per area divided by the area. ISO impact strength. Okay. Here, the area, this is the area of the material. as we shown in the earlier part that we take the dimensions of the block and then we calculated its area. The block is in the triangular form, so we will use the area of triangle formula to calculate its area 1 by 2, which is 1 by 2 base into height. We already take the values of base and height, which is 0.00495 and for height is 0.0021. So the area of notch comes 5.2 into 10 raised to power minus 6 meters square. So now the ISO impact strength equals to energy absorbed, which is 14.9 joule divided by the area 5.2 So the ISO impact strength comes 286.7 Here we see that the ISO impact strength comes in kJ, so our value is correct. Now, for the last part, we have to calculate the ASTM impact strength. The question is what ASTM impact strength is. ASTM impact strength is the energy absorbed divided by the thickness of the material. So, we already calculated the thickness of the material. So ASTM impact strength energy absorbed divided by the thickness. We know the energy absorbed is 14.9 and we converted the thickness into meter, which it comes 0.0093. I already calculated the value of ASTM impact strength, which comes 1588.4 joule per meter. So that's all for the calculation part. Now the other guy will explain the discussion and conclusion. Thank you.
I'm going to tell you about the readings and the data that we collected during the Izod experiment, and these all readings are available on this sheet and you can see it and it is quite visible. And this is the image of the aluminum stripe that we used in the experiment, and this is the top view of this aluminum stripe and this is the front view, and the length of this stripe was 76.34 millimeter and the width was 9.38 millimeter. And now we are going to calculate the depth of the notch, which is this one, and this is the top view of the notch and this is the front view. And it came out to be 2.02 millimeter and the base of the notch was 4.95 millimeter, and we know the length and the breadth was 9.38 millimeter and the length was 76.34 millimeter. And now I'm going to tell you about the angle of flange which we calculated on the meter of the Izod machine, and the angle of flange came out to be 64 degree and the energy that this aluminum material absorbed was 11 feet-pound, and this is the old reading that we calculated during the experiment. And thank you.
So, my name is Manmeet Saggu and I'm going to talk about the conclusion for this experiment. The main objective of the experiment is to determine the impact resistance of the materials by using Izod impact testing machine. This machine has a pendulum which swings and hits the materials, thus breaking it. Using this machine gives us the impact resistance in pounds and also give us the angle, so that using some formulas and there are given angles too, so we can find the impact resistance of the materials, thus finding the toughness of the materials. Yeah. While performing this experiment, we get familiar with Izod impact testing machine and its dangers related to it, mainly the dangers, yeah, and precautions related to it. So, but we have, if there are dangers, we have to take some precautions too. While loading the material, we would have to ensure that the pendulum is locked at a place at a spot. These are some things which we have to take care of. So it should be locked, the pendulum should be locked while loading. After placing the sample at the spot, we have to close the screen to perform the experiment or the lab, which will result in giving us the angle and measurement, so on. In the performance, we found out the toughness of the material. Yeah, basically we use aluminum for this. The toughness, we got the toughness. Coming off to the real life stuff which we can do with while performing this experiment. This is basically mostly used in automotive companies. They want to know the behavior of the material under different temperatures, so they heat the materials and they test it, they break it, and they found the toughness of the material at different temperature and how they will work. So in the vehicle, this is it's really necessary because vehicle run from cold to hot, and they run in different temperatures too. So this is a very, not a unique but very good experiment to know about the toughness of the material and using the machine. So yeah, this is all about it. Thank you very much.